this lecture, I will try to explain the operation of relay and circuit breaker. Relay and circuit breaker. So in my last class or last lecture, I told you the basic functions of relay and circuit breaker. Relay is a sensing device. It detects the fault and initiates the operation of circuit breaker. So this relay initiating the operation of circuit breaker is technically called as sending a trip command to the circuit breaker. Upon detection of fault, relay sends a trip command or trip signal to the circuit breaker. Circuit breaker, after receiving the trip command from the relay, circuit breaker moves its moving contact and isolates the faulty section. So circuit breaker as having two contacts, as I told you. So let us suppose this is a fixed contact and this is a moving contact. So the moving contact of the circuit breaker will be pulled and circuit breaker opens its contacts. So by doing so, circuit breaker is interrupting the fault current to flow. Okay, so that is a basic function of relay and circuit breaker. Remember that circuit breaker by itself doesn't have the sensing capability, so it cannot sense the presence of a fault. So it only relies upon the information or trip command given by the relay. So the operation of relay is very important. It has to sense the faulty condition and it has to give the trip command or trip signal to the circuit breaker within no time or as early as possible. Then only the circuit breaker can understand the presence of fault and it will try to isolate the faulty section. You can see that both of these devices are interdependent. Neither circuit breaker nor relay is a standalone device. They should be used mutually. So let us now try to understand let's try to understand the basic operation of relay and circuit breaker. For this, I am taking a single line diagram of a distribution feeder. So let us suppose this is the feeder feeding some load. In the last class, I also told you that we don't connect relay directly to the system. It is connected via instrument transformers CT and PT. So this is the bus bar. We can see there is a CT here connected to a coil. So this coil is called the relay coil. This coil here is called the relay coil. This whole setup here, this whole thing is called the relay. Of course, there is a spring also present here. Okay. Let me name all its parts. So this circuit here is called the trip circuit. So this coil here is called the relay coil. So we have the current transformer here. So this is the circuit breaker. Okay. So here we have a plunger or a metallic piece called as plunger. So there is a circuit and there are two contacts in the circuit I'm naming them as A and B. So these A and B are called as the trip contacts. Okay. Here there is a spring. So this is called as control spring. Control spring. So we can see that relay is connected to a circuit called trip circuit. So there is a relay coil which is being fed from the CT secondary. So the secondary of the current transformer is feeding the relay coil. So whatever current that is flowing in the feeder is stepped down by this current transformer and it is fed to the relay coil. So let us suppose the current that is flowing in the relay is IR. IR is nothing but the secondary current of the current transformer. Okay, actually it will be connected like this. Okay. So the secondary, whatever is this is the secondary of the CT. So that is connected to the relay coil. So this is the relay coil RC, let us suppose, and this portion is the CT. Sorry, I think I have drawn it in a reverse way. Let me erase this. CT secondary will have more number of turns, right? So this is the CT will step down the current actually. So this is the CT. So this is the feeder or the line. This is the feeder. Okay. This is the feeder. And here there is the relay coil. This is the relay coil. The relay coil. Okay. So CT primary is aligned with the feeder, whereas the CT secondary current is fed to the relay coil. So that this whole thing is symbolically shown like this here, because these are the various parts. Now let us try to understand the operation. So when the feeder is healthy, or when there is no fault on the feeder or any of the loads connected to the feeder, this plunger here will remain in this position that is shown in the figure. If in case the plunger closes the contacts A and B, this trip circuit will get activated. If the trip circuit gets activated, the coil here shown here gets energized, and this contact of the circuit breaker, which is the moving contact of the circuit breaker, is pulled in this direction. If the moving contact of the circuit breaker is pulled in this direction, the circuit breaker isolates or opens the circuit and the feeder will get de-energized. Okay, so I'm repeating the same thing again. Let us suppose there is a fault here. Let us suppose there is a fault here on the feeder. Let us try to understand the operation of Reliant circuit breaker. See here, there is this plunger which is present inside this coil or embedded inside this relay coil. So this relay coil is energized from the secondary of the CT. So there is an electromagnetic attraction force on this plunger. So this plunger will have a tendency to come in this direction because of the electromagnetic pull of this relay coil. Okay, but this plunger movement towards the relay coil, or the plunger movement to close the contacts A and B, is opposed by the control spring. There is a spring attached to the plunger. So there are here two opposing forces. One force is a spring force and the other force is the electromagnetic attraction of the relay coil. So the electromagnetic attraction force of the relay coil is trying to close the trip contacts A and B, whereas the force created by the spring is trying to retain this plunger in its position such that the trip circuit is open. In other words, the control spring force is opposing the force of the relay coil, force generated by the relay coil. Okay, so there are two torques. operating, or two forces operating inside a relay. One is because of the relay coil. So this is trying to, this force or is trying to close the contacts A and B. So by pulling the plunger, right? Whereas the other force, which is generated by the spring, control spring, is opposing the force generated by the relay coil. Force generated by the relay coil. So there are two opposing forces acting inside a relay. If you can see this force, which is trying to close the contacts A and B, which is due to the contacts A and B, is by the virtue of the current drawn by the relay coil. So relay coil is drawing a current and there are certain number of turns. So there is an MMF, number of turns into current. So that MMF is creating the force on the plunger, and that is creating the attraction force, which is attracting the plunger such that the trip circuit is closed. So the magnitude of that force depends upon the amount of current drawn and number of turns of this relay coil. The magnitude of force generated by this relay coil on this plunger depends upon the number of turns of the relay coil and the current drawn by the relay. So the current drawn by the relay is nothing but the secondary current of the CT. The secondary current of the CT in turn depends upon the current that is fed in the feeder. After all, this CT is reflecting or stepping down the current present in the feeder. Let us suppose if it is a 100/1 CT, so if 100 amperes is flowing in this feeder, 1 ampere will be reflected here. Okay. So if 50 amperes is flowing, 0.5 amperes will be coming into the relay coil. So whatever magnitude of current that is flowing in the feeder, its replica will be sent to the relay coil. So the torque generated by the torque or force generated by the relay coil on the plunger depends upon the relay coil current and number of turns. Let us suppose the number of turns after designing a relay, let us suppose they are fixed. So the torque generated entirely depends upon the relay coil current. Under normal conditions, this relay coil current is not sufficient enough to generate a force greater than the spring force. I'm writing down that. So under normal condition in the sense no fault condition. No fault condition. So IR is within limits. Within limits. So this, when the IR is within the limits, then the force generated by the relay coil, okay, cannot close contacts A and B. Okay, so this is under normal condition. When there is a fault, so under faulty condition, so when there is a fault, what happens? So when there is a fault, huge amount of current flows in the feeder and the current drawn by the relay also will increase. If IR increases, at certain value of IR, the force generated by the relay coil on the plunger exceeds the force, opposing force by the control spring. So when there is a fault, IR will be high because IR is nothing but the current, the secondary current of the CT. So if the primary current of the CT increases, the secondary current of the CT also increases based on the turns ratio, and the relay coil current increases. So this causes the force by the relay coil to increase. So force by the relay coil increases. So the plunger will close contacts A and B. Contacts A and B are now bridged or closed by the plunger. So when the force increases, in the sense that this relay coil force is greater than the spring force. Under this condition, the plunger closes the contacts A and B. So the plunger is pulled down and contacts A and B are closed. As I told you, when contacts A and B are closed, the trip circuit gets energized. Okay, when the trip circuit gets energized, this coil here gets activated. This creates a force on the moving contact of the circuit breaker. So this is a circuit breaker here, and the moving contact of the circuit breaker is pulled in this direction because of the energy of the relay, this coil. Once the moving contact of the circuit breaker is pulled in this direction, then the circuit breaker opens. When the circuit breaker opens, this fault is no longer fed from this bus bar. In this way, this faulty section is isolated by the circuit breaker and relay. Here, when this fault has occurred, this relay closed this trip contact A and B, or closed the trip circuit. Once the trip circuit is closed, circuit breaker has opened the moving contact. Okay, so the sensing part, the fault has occurred and trip circuit is closed. Once the trip circuit is closed, CB is opening. So the sensing part is taken care by the relay. So this circle, it is closing the trip circuit. So closing the trip circuit is nothing but giving a trip command to the circuit breaker to operate. In this way, relay initiates the operation of the circuit breaker and circuit breaker isolates the faulty section. Here, I told you that there are two opposing forces acting in the relay. One is the force because of the relay coil. So this force is called as operating torque. This force is called as operating torque. Another force is due to the control spring. So this is called as restraining torque. So the operating torque is always trying to operate the relay. Operate the relay in the sense, close the relay contacts A and B. Close the trip contacts A and B. This restraining torque is opposing the operating torque. So is it really necessary? Restraining torque, is it really necessary? What happens if there is no restraining torque? If there is no restraining torque, there is a chance that relay even operates under healthy condition or no fault condition, right? Since there is no opposing torque, since there is no spring or opposing force, even small amount of current can pull the plunger down, and the trip circuit will be closed and circuit breaker will be open. Okay, this should not happen. Relay and circuit breaker should only operate when there is a fault. So to restrain the operation of relay under healthy condition or under no fault condition, this control spring or the torque generated by the control spring, that is restraining torque, is necessary. So restraining torque restrains the relay operation under healthy condition, healthy or no fault condition. So this torque is very important. So it restrains the operation of relay under healthy condition. It is also important because relay has to reset to its initial position. Relay has to reset to its initial position once the circuit breaker is open. Let me explain that again by drawing the diagram. Although it is time consuming, but please bear with me. So this is a trip circuit. This is the plunger. This is a spring here. This is a circuit breaker. So here we are having this CT and the relay coil. So let us suppose there is fault here. So there is a fault, and due to the increase in current in the relay coil, the plunger is pulled down. In the sense, the operating torque created by the relay coil exceeded the torque generated by the torque or force generated by this control spring, and this plunger is pulled down and trip circuit is closed. Once the trip circuit is closed, circuit breaker moving contact is pulled apart and circuit breaker is now in open condition. Normally the circuit breaker is under closed condition. Okay, when the trip circuit gets activated or relay closes the trip circuit breaker will open its contacts. It's a normally closed contact. Under faulty condition or under the trip command given by the relay, the circuit breaker will open its contact. So once the contacts are open, there is fault here. Fault is no longer fed, right? In the same at the same time, even the CT is not receiving any energy because there is an open circuit here, right? Since there is an open circuit here, the CT gets de-energized and the relay coil current IR is 0. When the relay coil current IR is 0, what happens to the torque generated by the relay coil? That is the operating torque. What happens to the operating torque? So operating torque is the torque that has drawn the plunger or that has made the plunger to close the trip contacts. Okay, now the plunger is in this position, right? It has bridged the contacts. So this is the contact A and B. These contacts are closed. So there is a coil here. So these contacts are closed. These contacts A and B here are closed by this plunger. Since there is no current and there is a spring force acting on it. Since there is no current, the spring force will dominate because operating torque is 0 because there is no current. The spring force will dominate and this plunger will be pulled back to its normal position. So that is the second purpose of the restraining door. I'm repeating this again. See, when there is a fault, the current in the relay coil increases. When the current in the relay coil increases, the operating force generated by the relay coil increases. When the operating force generated by the relay coil exceeds the control spring torque or the restraining torque, the plunger gets attracted and A and B contacts are closed. So this is the trip circuit. Trip circuit is closed. Once the trip circuit is closed, circuit breaker contacts are open. Circuit breaker's contacts are open. So that is the Reliant circuit breaker operation. But what happens once the circuit breaker contacts are open? That is very important to understand and keep in mind. So when the circuit breaker contacts are open, relay actually comes back to its reset position or initial position. So this is the initial position of the plunger. So this will happen again only because of the presence of the spring. So let us see how does that happen. See, the circuit breaker has opened now. So there is an open circuit here. The CT, the fault is now no longer fed and it's got isolated. The CT also get de-energized because of this open circuit and the relay coil current is 0. If the relay coil current is 0, so the torque on this plunger is 0. The operating torque is 0. So the two opposing forces, there is a control spring force as well as the operating torque force, out of which the operating torque force is 0. When the operating torque force is 0, controlling torque or the restraining torque generated by the control spring dominates and it will pull back this plunger to its initial position. So the plunger will now come back to its initial position. That is, its contacts A and B will now be separated. There is the bridge between A and B is now separated. Now trip circuit is open. Okay, so that is the another aspect of the controlling torque. Here are the restraining torque. Here I told you that restraining torque is restraining the relay operation under healthy condition. So under healthy condition, restraining torque is not allowing the relay to operate. That is good. Relay should not operate under normal condition. It should only operate when there is a fault. Okay. The second purpose of the restraining torque is to reset the relay. It means that when the circuit breaker opens its contacts, the relay contacts also should open. So that is being done by this controlling or restraining door. Okay, so these are the two functions of the restraining door. I hope you understood the basic operation of relay and circuit breaker. Thank you. Please subscribe to Easy VTech channel.